Hey guys, and welcome back to another video on the channel. In today's video, we're going to be trying to evaluate this monstrous integral that my friend sent me. I'm just going to start writing it out because it's absolutely massive. Yeah, let's keep that size. Negative x to the power of x minus 8x to the power of x minus 1 plus 25x to the power of x minus 2 divided by x e to the log, oh wait, there's x there, sorry. It's a very big integral, so I'm just going to write it all out really quick. Minus 7 e to the power of x log of x, all on x, plus 6e to the power of x log of x divided by x squared dx. Righto, this is the integral. Now, I don't know how long this video is going to be, but we're going to slowly break it down. So, the coolest part about this integral is actually there's a very neat trick that makes it a lot easier than it looks. So, if we look at the top here, we're going to pretty much try and factorize something out. Now, let's rewrite each of these terms here. So, we know we can't really rewrite that term any further, but let's try and rewrite this guy here. So, let's say I wanted to factor out an x to the power of an x. Because do you agree, if we have negative 8x to the power of x minus 1, that is the same as negative 8x to the power of negative 1 times by x to the power of x. Because if you were to multiply those, you would add the indices and you would get this corresponding thing. And same here with this one here. So if you have 25 to multiply by x to the power of x minus 2, if you factor out an x to the power of x, you get this. You get 25 x to the negative 2 times by x to the x. So we can see on the top here, we can actually factor out an x to the power of an x. So let's just move this guy to the side real quick, and let's just do that. So rewrite our integral again. But we'll factor out an x to the power of x to the power of x. So what we're going to have here, the first term is going to be negative 1 minus 8 to the power of negative 1, which is just 8 on x because of index laws. Because if you have a negative exponent, you can put it over a fraction and make it positive. So 8 to the power of negative 1 is 8 over 1. And likewise, when we have 25x to negative 2, that's going to be 25 on x squared. So we'll have plus 25x squared. And that's all we're doing on the top of our integral. Now, we're not even integrating yet. We're just going to slowly break down our little thing we have here. Now, there's an e there. E log of x minus 7 e to the x log of x, all on x, plus 6 e to the x log of x, x squared dx. Righto, now what we're going to do is try and factorize something in the bottom there. If we can see in the bottom, what is common in all of them? This term here. So we can factorize that out as well. So we have the integral of x to the power of x on negative 1 minus 8 on x plus 25 x squared. Multiply now. If we factorize that out, we'll have e to the x log of x. And then we're going to have the following. X minus 7 on x plus 6 on x squared. Now here's the really cool part. Let's take a look at these guys right here. If you have e to the x log of x, you can bring this x up here, can't you? So you have e log of x to the power of x. These two will cancel out because they're inverses of each other. So that turns into pretty much whatever's left in here, which is x to the power of x. So e to the power of x log of x is the same as x to the power of x. So what we can actually do is cancel those guys out. So all we're left with is this following integral. negative 1 minus 8 on x plus 25 x squared all over x minus 7 on x plus 6x squared dx. That's a lot easier than what we had at the start, isn't it? Now, let's just try and make this a bit easier again as well. So we can see we've got denominators with x squares and stuff. Why don't we just multiply the top and the bottom by x squared to pretty much make things more look pretty, because that will cancel out. That will be an x on the top and that will be an x cubed, so we won't have like x's on the denominators on everything. So if we apply that, pretty much what we're going to have is pretty much this following integral: negative x squared minus 8x plus 25 over, and then the following will be x cubed minus 7x plus 6 dx. Ta-da! We've now got still a really hard integral, but it's a lot easier than what we started with at the moment. So what we're going to do is we're probably going to apply partial fractions to this, or see if we can, because I can't see a u substitution appearing anywhere in this bit. But what we're going to do is try and factorize the bottom bit. So we can see at the bottom we have just a cubic, pretty much, this guy here, and we're going to try and break it down to its factors. So we're going to let it be p of x. So p of x is x cubed minus 7x plus 6. I'm not going to try 1 or 2. Actually, no, I won't try 1 because I'll get 1 here and 1 here. And it's just not going to work out nicely, because a cube of a negative number is still going to be negative, and that won't just work. But I'm going to try 2 straight away. So p of 2, so I'm going to let x equal 2, so I'll go 2 cubed minus 7 times 2 plus 6. So I'm going to have 8 minus 14 plus 6, add all those together, and you get 0. So therefore, x minus 2 is a factor of p of x. So we're going to apply long division to this fellow polynomial. So x minus 2 divided by x cubed minus 7x plus 6. So now we're going to think, alright, how many times can x fit into x cubed? Well, x squared times. So you put x squared there, and then you multiply the x squared by this bit here. So x squared times by x minus 2 gives you x to the power 3 minus 2x squared. Then you're going to subtract this whole bit down here. So we got x cubed minus 2x squared. And we know we've done it correct because that term and that term cancel out. All we're left with then is 2x squared minus 7x plus 6. And then we do the whole process again. So 2x squared divided by x gives you 2x. So you're going to get plus 2x. And then 2x times by x minus 2 gives you 2x squared minus 4x. Subtract down here, 2x squared minus 4x. That cancels with that. Then you're going to have minus 3x plus 6. Minus 3 will go up here because minus 3x divided by x is minus 3. Minus 3 multiplied by x minus 2 gives you negative 3x plus 6. And if you subtract down here, we get 0 because it's a factor. So when you divide this little guy by this polynomial, you get this following quadratic. So that means if well, there's not much room here. So pretty much our integral, which was negative x squared, what was it, minus 8x plus 25 on, and then our polynomial, what was it, x cubed minus 7x and then plus 6, I believe it was, dx. Right, that is equivalent to this integral here. So minus x squared minus 8x plus 25 all on x minus 2 times by this quadratic here. So x squared plus 2x minus 3. Righto. So the reason why we can do that is because this is equivalent to that. If you were to multiply that out, you would get this guy here. So now what we're going to do is try and factorize this guy here. So we think of, alright, what two numbers multiply to give -3 and add to give 2? Straight off the back I can think of 3 and -1. So, if you factorize that, that is the same as x plus 3 multiplied by x minus 1. And you can double check that if you were to multiply that out, you would get that there. So now what we have is the integral from negative x squared minus 8x plus 25 all over 3 factors, pretty much. So since we have 3 clean factors, what we can do now is partial fractions. So we're going to ignore, now notice we haven't done any integration yet. All we've done is lots and lots of algebra. Even though the integral is there, there's been no calculus at any point in this video so far. And there still won't be for a bit, because we've got to do more algebra with this guy here. So now all we're going to do is pretty much break this guy up into partial fractions. So we can see we've got 3 pretty much factors, so we can break it up into the following. So this will be equivalent to a constant, let's say a, over x minus 2, plus b, which is a constant, over x plus 3, plus c, which is a constant, over x minus 1. So a, b, and c are numbers at the moment. And what we're going to do is pretty much find those. So what we're going to do is multiply both sides by this following expression here. The reason why is because it'll cancel on the denominator here, and it'll actually cancel with terms on the left hand side as well. So if I multiply this entire thing by this side, and I multiplied it by this side over here as well, if I have enough room, I don't know if I'm going to have enough room, I'm going to have to make it a bit smaller, or move it down. So if I multiply it over here, we can see that cancels with that, and these bits will slowly cancel these other bits. So what we're going to have is negative x squared minus 8x plus 25. Multiply this first bit to here, that x squared, the x minus 2 will cancel out, but you still have this bit with the a, so you're going to have a multiplied by x plus 3, and then x minus 1. And then it's going to be the same with these guys here. So b will have the other two factors that aren't this, so this will have x minus 2, and this will have x minus 1. And c will have the other two factors that aren't x minus 1, so c will have x minus 2 multiplied by x plus 3. And that's it, fully done. So what do we do now? Well, we've got to try and equate things. Now, do you notice, because these are like proper factors, if I substitute some of these numbers in here, things are going to start cancelling out. So for example, if I put in x equals -3, I'm going to have, alright, negative of -3 squared minus 8 times by -3 plus 25 is equivalent to a multiplied by -3 plus 3 on, well, -3 minus 1 plus b times by -3 minus 2 multiplied by -3 minus 1 plus c, which is -3 minus 2 multiplied by -3 plus 3. We can see that would be 0, so that term's gone, and so is that term, because that will be 0. So that's gone and that's gone. So all we're going to have is, alright, this will be minus 9, this will be plus 24, and this will be 25. This will be positive, this will be negative still. This is going to be equivalent to, alright, -5 times by -4, which is going to be 20b. Now let's try and add these guys together real quick. So, arithmetic, basic math. Okay, so if I add those guys together, I'm going to get 49 minus 9, plus -9 equals 20b. So I'm going to have 40 equals 20b. I nearly couldn't do basic maths for a second. So if I divide pretty much both sides by 20, your b is going to be 2. So we found the first number straight away. Okay. Now, we got to do that for the other ones as well. So all I'm going to do is copy and paste this stuff because I can and I control the video, and there's nothing you guys can do about it. So I'm going to copy and paste this and do the same thing, except I can substitute what b is now because I know b is 2. Copy, paste, and replace that with 2. Righto. What else we can do? We can sub in x equals 1. Make that 0 and make that 0. So we can find c. So negative of 1 squared minus 8 of 1 plus 25 is equal to c times by, was it 1? Yep, 1 minus 2 multiplied by 1 plus 3. So we're going to have, well, that's going to be negative 1 minus 8 plus 25 is equivalent to, and that's going to be negative 4c. Minus 9 plus 25 equals negative 4c. Divide by, that's going to be 16, I believe. Divide by negative 4, divide by negative 4, and then c is going to be negative 4. Ta-da, we found c. So we're going to copy and paste that thing again and do the same thing, except we now know it's b is 2, I think it was, and c is negative 4. So 2 and negative 4. And then finally we're going to substitute x equals, what one haven't we done yet? 2, that's it. That turns to 0, that turns to 0. So what we're going to have is pretty much negative 2 all squared minus 8 times by 2 plus 25 is equal to a multiplied by 2 plus 3 and 2 minus 1. This is going to be 4, negative 4 minus 16 plus 25 equals 5a. That is going to be 9 minus 4 plus minus 4. So what we're going to have is 5 equals 5a. So therefore a is 1. Righto. So in hindsight, this here, negative x squared minus 8x minus plus 25, I think it was, over pretty much all these guys here, x minus 2, and then x plus 3, x minus 1, is equivalent to the following pretty much. 1 on x minus 2 plus 2 on x plus 3 plus minus 4 on x minus 1, and that's it. I think those are all the numbers. Yep, righto. All you're going to do now is integrate. Little dx there, integrate dx. So if you want to work out this integral, just integrate these. And we can do this quite easily now because a bunch of those are just going to turn to logs because it's 1 over something. So the first term is going to be, well, 1 natural log of x minus 2 plus 2 natural log of x plus 3 minus 4 natural log of x minus 1 and then plus c. So natural log of x minus 2, move the 2 in there, so you go plus natural log of x plus 3 all squared minus natural log of x minus 1 to the power of 4 plus c. And if you want, you can leave it like that, or you can combine it using log laws. So the first one will be log of x minus 2 multiplied by x plus 3 all squared, and then divide by this guy here. So x minus 1 to the power of 4, absolute values, plus c. So in hindsight, this guy is our integral from all the way up here. So now move this guy to the side and we can attach a value to that. Oh god, that's messy. Let's move that out of the way. I'll rewrite it like this. X minus 2 on x plus 3 squared on x minus 1 to the power of 4 plus c. Ta-da, that's it. So this chunky integral is just that, pretty much. I know, so easy. No, actually it was really hard. Just this factorizing bit, a lot of people wouldn't have been able to do because they wouldn't have known this fact here. And then, yeah, a lot of hard work, but we got there in the end. I hope you enjoyed this video. If you want me to cover crazy integrals, leave some in the comments or email me. And yeah, I'll see you in the next video.